Hi everyone. So the goal of this video is to better understand scientific notation. It's a common way that we in science write numbers, especially numbers that are really, really big or really, really small. I'm going to post a very engaging video or a video from a very good website called Veritasium that kind of explains scientific notation. If you don't know about Veritasium, just a little plug, it's a great channel. He's a great uh, entertainer, and he covers all kinds of things for the past like 15 years on science. Anyways, so let's talk about how to convert some numbers that are maybe in our usual form, and we can convert them to scientific notation. So the rules are you have to just move the decimal point until it is a place where you have one digit to the left of the decimal. So let's just see what that looks like. So I have this number here, and technically the decimal would be right here, right? I want to move it until it is in a situation where there's one digit to the left of the zero. So I want to go until it's right here. All right, so I'm going to move it that far. I'm going to go 1, 2, 3, 4, 5, 6. I had to move it 6 times, and then I would have 2.3. Now, if I have to move it 6 times, then what I do is I say times 10 to the 6th power. All right. Basically, what I'm saying there is I'm taking 2.3 and I'm multiplying it by 10 to the 6th. 10 to the 6th is 10 multiplied by itself 6 times. If you did that in the calculator, 10 times 6 times 6, or 10 times 10 times 10 times 10 for 6 times, you would end up with, pretty sure you end up with a million. And then I'm saying, okay, multiply 2.3 by a million. So I get 2,300,000. All right, that's pretty much it. All right, so I'll just write that out. So basically, another way that we're doing this is we're just saying it's 2.3 times 1 million, right? If you did 2.3 times 1 million, you'd get this number. All right. Now, if I wanted to have a small number, if I want to move that to scientific notation, I want to do the same thing. I want to move this decimal until it is in a situation where there is one digit to the left of the decimal, right? And I'm not really counting zeros here, so I want to get rid of all these zeros. So I'm going to go 1, 2, 3, 4. So I had to move it 4 times. So I'm going to write 2.15 times 10 to the 4th. Now hold on, I moved the decimal to the right. So anytime you move the decimal to the right, what you're really doing is you're making the number kind of bigger when really the number was originally small. So to represent that in scientific notation, we would say negative 4. It's 10 to the negative 4. So if you're moving the decimal to the left, you have a positive number here. If you're moving the decimal to the right, then you're going to have a negative number here. All right. Now let's talk about actually converting some units here. All right, let's say I have 4.31 kilometers and I want to turn that into meters, but I want to convert that with scientific notation. There's a couple of ways I can approach it. I'll maybe do the simpler way, even though it might be a little bit longer. And just one thing I'll point out here is it doesn't really matter what units we have here, right? We have meters in this case. I could have I could have amps, I could have coulombs, I could have I don't know, just about any kind of measurement that we've used in physics. All right. Um, so I could have joules, I could have watts, whatever, right? The key idea here is that I have kilo though. Kilo means 1,000. So another way to kind of say this is I have 4.31 times 1,000 meters, right? And so if I want to convert my kilometers to meters, I just need to take my 4.31 and multiply it by 1,000. And that would be 4,310 meters. All right, but I wanted my number in scientific notation. I want to still have a decimal here. So if my decimal was here and I want it here, I need to move my decimal 3 times. 1, 2, 3. So what does that become? That becomes 4.31 times 10 to the third, right? Because I moved my decimal 3 times, My exponent here is 3. Okay, let's do maybe a trickier one here where we have to move the decimal to the right. So I have 34.9 millimeters, and I want to convert that to meters. All right, so 34.9 millimeters. Again, it doesn't really matter what units I have here. What matters is milli. Milli means 1,000th. So you might kind of recognize the pattern of what we did up here. I'm going to do that same thing for this one. I'm going to do 34.9 times 1/1000th. Or another way to say that is 34.9 divided by 1,000. So we don't really need to put that into a calculator. What we're really doing here is we're saying that we're going to take 34.9. Well, we could put it in a calculator. Let's just see what that looks like. Just so you guys believe me when I tell you certain things. 34.9 divided by 1,000. Okay, so you can see now in the decimal form, that would be 0.0349. Okay. Now what I said though, I said I want this in scientific notation. So to do that, I need to move my decimal. I need to move it until there's one digit to the left of the decimal. So this 3 here is perfect. I'm going to put the decimal right there. So I need to move it 2 times. 1, 2. So if I move the decimal 3 times, or I'm sorry, I moved it 2 times, I have 3.49 times 10 to the negative 2. Now it's 2 because I moved the decimal 2 times, and it's negative because I moved it to the right. All right, let's do a couple more things here just so that I can give you lots of exposure to lots of different ideas. All right, let's convert 14.0 micrometers to meters. Again, doesn't matter what I have here. I could have any kind of unit. What matters here is micro. Micro means 1 divided by 1,000,000. All right, that's pretty small. And you'll see when we talk about measurements of charge, we usually deal with micro coulombs. So that's why this is important for our unit. All right, so let's say I have 14.0 micrometers. Let's do a little shortcut here just to make it simple. I know that I have 14 and my decimal's here. I know that because I have all these zeros here, well, actually, let me just do it the way I did it before. Let me just divide this by 1,000,000, just so you guys, believe me when I show you things. 14 divided by, okay. All right, so this, see, there's a lot of zeros there. And that could be quite annoying, keeping track of all those zeros. 1, 2, 3, 4. Okay, so this is what it looks like. Now I need to move my decimal to here. So I need to go 1, 2, 3, 4, 5. I'm going to move my decimal 5 times. So I should have 1.4 times 10 to the negative 5. Okay, now how do we do math with these numbers? It's actually surprisingly easy if you know the rules. Now I can do this in the calculator, and actually I'll show that to you in a minute, but let's just do this by hand really quickly. There's 2 major rules. Rule number 1 is you're going to multiply the numbers in the front. All right, so 2.0 times 3.0, well, that's 6.0. All right, now I know I'm going to have an exponent, so I'm going to put times 10. And now the question is, well, how do I figure out my exponent? Easy. You add your exponents. 3 plus 5 is 8. And you're done. Crazy easy, right? Okay, let me just show you that in a calculator. And I'll even show you how to do it on a calculator. So say you have these 2 numbers. And I'll show you a little shortcut. I'm going to do 2, and here's the shortcut. Second, and then there's a little button here that has EE. You're going to hit that button that says EE. It's going to put an E on your screen. And now I put 3, all right? And then I'm going to say times 3E5. This is a shortcut for saying 2 times 10 to the third, and this is 3 times 10 to the fifth. Okay, I got a really big number, and I really wish the calculator would give me the answer in scientific notation. There isn't really a way for me to tell it to do that though. But I can rest you sure that this number 600000000 that you see on this calculator is the same thing as this, right? This basically says you're going to have a 6 followed by 8 zeros. And that's exactly what this is here. Okay, let's do one last thing, dividing. All right, so the multiplying had very simple rules. Dividing has very simple rules as well. How do you do this? Well, you do your 9 divided by your 4. 9 divided by 4 is 2.25. And then I'm going to do times 10. I know I have an exponent. Now, before we added our exponents, when we're dividing, we want to subtract our exponents. 9 minus 6 is 3. And that's it. Another way to say this would be 2250. All right. So if I did this in the calculator, if you don't believe me, watch. 9 to the ninth power divided by 4, 6. There you go. Boom. All right, so I hope this was useful. This will be useful in terms of understanding exponents and scientific notation if you want to better understand Coulomb's law and what we're doing right now in physics. But the whole reason why I want you to understand this is that sometimes in physics, our measurements are really, really small. And it's really crucial to understand these really, really small numbers. In physics, our numbers can also be really, really big. We can have masses that are times 10 to the 27th, like the Earth, or times 10 to the 30th, like the Sun. We could have measurements in science as small as times 10 to the negative 31, right? The mass of an electron is some number times 10 to the negative 31. It's so small. And if you want to be able to do calculations with those numbers, you have to understand scientific notation. All right, I'll leave you there. Good luck.